Hey, I am Avas and I'm going to walk you through Vantage, the ASO audit agent I built for this take home. The thing about most app store optimization tools is that it's generic. Improve your title, add screenshots, useless. The bar I set for this was every single recommendation has to point at a real data point from the listing, and for anything text based, like the title, the subtitle, or the description, it has to give you a concrete before and after rewrite. So let me just show you it working first, and then I will get into how it's built and the decisions I made. I'm going to paste a URL here, and then I'm going to start audit. Now it runs the full audit and it streams what it's doing as it goes. First thing it does is fetch the surface metadata and ask me to confirm. Is this the app you meant? This is the real checkpoint, and here's the part I want to flag. Under the hood, the workflow has generally paused here. It serialized its state to a database and stopped. It's not polling, it's not a fake line side step. The workflow is suspended, waiting for a human. So when I click on yes, audit this, it runs the full audit and it streams what it's doing as it goes, reading reviews, scouting competitors, scraping the listing, then the actual scoring pass. Those data steps run in parallel, so we are not waiting on them one at a time. While this runs, every status line you are seeing in a real workflow event streamed over server sent events. The UI isn't guessing, it's reflecting the actual pipeline. And here's the report, score out of 100 at the top with the plain summary. Then every dimension, a lower score first, so you know where to look. Each one cites the actual evidence it scored on. Scroll down, we'll have quick wins. Then we have high impact changes, and this is the most interesting part. Here it is not telling me to like optimize a subtitle, it's giving me the exact rewrite with the character count because Apple caps these fields. And down here we have the competitor comparisons. These are the real competitors in the same category pulled live. You can share it, or you can even export it in PDF or JSON files. Okay, that's the product. Let me show you how it's actually built, because that's where the interesting decisions are. So the brief asks for idiomatic use of Mastra's primitives like agents, tools, workflows, and skills. And I was deliberate about using each one for the job it's actually good at. So the workflow is the backbone. You can read the whole pipeline right here. Resolve the URL, fetch metadata, confirm, that's the suspend, then gather evidence in parallel, run the audit, and then assemble the report. Each of these data steps is a master tool, and how I mount them into the workflow. Now the tools aren't decorative wrappers sitting in a folder unused, they are the actual load bearing IO of the pipeline. So the agent has exactly one job, which is to judge. So it reads the evidence and returns a score from 0 to 10 for each dimension with the reasoning. That's it. It never sees the final number. Then we have skill.md, and the skill is the ASO rubric itself. The scoring framework lives in this file, not buried in a prompt string. The agent loads it through Mastra's workspace skills API at startup. Now the decisions I would actually defend in a review. First, the LLM judges, but code scores. So this was the most important call. I never asked the model for the overall number. It gives me 0 to 10 per dimension. The weighted sum is computed right here in score.ts. Because if you ask a language model to do a weighted average across 10 dimensions, it will hallucinate and you will get a different number every run. Giving it only the judgment task and keeping the math in code makes the score reproducible. Same evidence, same score every time. A small thing that I want to show you. So the rubric weights in the spec actually sum to 110%, not 100. Instead of silently clamping, I normalize them so the score always lands in zeros to 100, and every dimension keeps its intended weight. It's a one liner, but I caught it and handled it on purpose. Secondly, and this is my favorite one because it's a real engineering story. I load the rubric through Mastra's workspace skills API. The natural next step is to register that workspace on the Mastra instance. I did that, and the audit started hanging and timing out with empty responses. So I root caused it. When you register a workspace, Mastra attaches workspace instruction processes to every agent, and those stall the single structured output calls this whole order depends on. I verified it in isolation. The bare agent responds in 2 seconds. The registered one times out, so I made a deliberate trade off. I use the workspace purely as a skill source and I don't register it on the instance. It's documented right here in the code, so the next person doesn't undo it. Uh, that's the kind of decision the framework won't make for you. Third, competitors. Natively, you would search the App Store for the genre name like music or education. That returns junk. It matches the literal world, not actual rivals. So instead, I see the search from the app's own descriptive keywords, the part of its name and subtitles that says what it does, and then I bias toward apps in the same category and storefront. Uh, the difference is night and day. For example, for a food delivery app, the genre search gave me individual restaurant apps. The keyword search gave me the actual delivery competitors in that region. Fourth, honesty about what you can't see. So the iOS keyword field, the 100 character one, this one, it is private, so no public API exposes it. Lazy audit would just make something up. This one marks those dimensions as limited. So I scores them on best practice only and surfaces are data gaps. That list at the end of telling you exactly what couldn't be observed. So I would rather be honest than confidently wrong. And the data layer is like tired so nothing blocks. Apple's APIs are free and keyless, so they always run. Firecrawl and the keyword intelligence are optional enrichment. If a key is missing or a call fails, they degrade to empty and the audit still completes. It never hangs waiting on an optional source. So on the engineering side, there's a Zord validation at every boundary. The Apple's APIs in the model's output, the events to the UI. The Apple clients are pure functions with no framework imports, so they are unit testable offline from fixtures. I'm going to run a test here. So it has 49 tests, which includes URL parsing, the scoring math, a contract scorer that checks any audit output for semantic correctness, and an end-to-end test that drives the actual workflow, suspend or resume, and all with the network and the model stub. That last one guards the wiring, so a refactor can't silently break the pipeline. So that's my Vantage. It runs end to end on any public app store app. Just uh, npm install and npm run dev. Uh, Add the required keys. The providers are swappable with 3 environment variables. Add every decision and every decision I made that the brief left open is written up in the README.